Okay, let's run another demo. This time it's actually a feature that's been in Cryostat for a little while now, but we're going to be doing it with Cryostat 4.0 just to really illustrate this point. And I think it's a really important feature for Cryostat that hasn't been highlighted before in this video demo, on my channel at least, and it's been a little while since we've talked about it, so let's take a look. What I have here is a Quarkus application, and I'm doing it as a build, so the build is still running within this cluster, but what we can do is take a look at the source code so I can show you what it is that I'm working with. So if you don't happen to be familiar with Quarkus already, it's basically a web application framework for Java, for OpenJDK, and so you can use it for building web applications of various kinds, and in fact, Cryostat itself, since version 3.0, has actually been written using Quarkus. Quite a powerful application framework, very nice to use, but let's look at the specifics of this particular application under test. Basically, what we have is a very basic Quarkus sample application, almost all the defaults. The only thing I've really changed a little bit is that we're doing a multi-stage Dockerfile build, which actually this is from the Quarkus documentation. It's an example they give on how to do this. So it's a multi-stage build, and it's, in particular, this is the interesting part, is it's building a Quarkus-native image. What that means is this is not actually going to be a JVM bytecode Java application in the traditional sense. It's still written in Java as the language, so if we go take a look at some of the Java implementation here, this is regular Java. But the compiler is not the regular OpenJDK Java-C compiler that compiles down to a .class file and jar file to be executed by an OpenJDK JVM runtime. What you actually get at the end of this build is native machine code executable by your CPU directly. So it's going to be a Linux executable, an ELF file, which we can see here at the end of the multi-stage build. So stage 1 actually runs that compilation step, and stage 2 just copies this runner binary into the final runner image. And then in the end, our entry point is simply executing that binary file. So if you're familiar with other compiled languages like C, C++, Golang, Rust, that looks a little more like how that kind of ecosystem would work. But our language here and our framework are Java and Quarkus. So very cool, very powerful. Anyway, the point is, we want to be able to use this kind of application and all the advantages and benefits that it brings with Cryostat, because with this kind of paradigm of running things compiled ahead of time and running it as a native application, it all sounds great. It all sounds all fine and dandy, but as we all know, anytime you think you're doing performance work, anytime you're doing profiling, you need to benchmark. You need to test your hypothesis, prove that it actually is an improvement for your particular case. And I think that's fairly well understood. So a great way to do that, if you have an example like this Quarkus application, is to build it in both native and JVM mode, and then benchmark them head to head with your real applications, your real workloads, your real deployments. You can do both. And what's great about doing that with Cryostat and JFR is that JFR, if you do it right, can actually also be built into your native mode applications. So if we just take a look here at the application properties, this is all I have to find. Quarkus native monitoring. In this case, I've chosen all. You don't need to do all. You can do JFR, JMX server, and that would be enough for our demo today. But here I've done all just to make sure everything's included. What that means is that we can run this as a native application, a native binary, and it will have a JMX server. You'll be able to connect to it over JMX. You'll be able to query mbeans and mxbeans and invoke remote operations, including operations on the flight recorder bean. So you can do things like starting flight recorder recordings and downloading them over the network. The things that we need for Cryostat to work. So with all that said, let's go check on our build. It's still running. Actually, the build completed just now. Good timing. But our pod is still waiting to restart. So let's go ahead and see if I can restart rollout and have that start up for us. Okay, and there it is. So let's view the logs in this thing, and we can see indeed that Quarkus started up, and it said that it's running in native mode. Very cool. Let's modify this deployment just a little bit, because we need to actually turn on the JMX server and enable it so that we can do something with it. So let's go ahead, I'll do it again in the YAML view as usual, and what we need to do is here, we're going to add some arguments. And I think I can do it like this. So what I want to add first is this flag. Oops, this is not formatted the way I want it to be. This flag, which is going to tell the application, I was going to say the JVM, but the application, to turn on JMX on this particular port number. We're also going to add two more related flags to do with JMX, and that's these two. These are going to tell the application to not require authentication on the JMX port. That's just to make the demo quicker and easier. And likewise, we're not going to require SSL on that port. Also, I'm going to add two more flags to do with JFR. So the first one is to enable flight recorder. I think technically we don't need that one when we have the second. And the second one is going to start a flight recording when the application actually does start up. And that's about it. I'm also going to just reuse this port number. We're not actually going to use 8443, so we're going to make that 8761 to match our JMX port. So let's go ahead and save that, and that'll cause our pod to be scaled down and back up again. And there we go. So let's just validate that that did something okay. We're going to go back into our pod logs. It seems to be up and running just fine. Okay, if you watched my previous demo, we can do the traditional thing with Cryostat of modifying the service for our application so that Cryostat can discover the JMX port. So let's go ahead and do that now. What I'm going to do is name this port JFR JMX and point it at the JMX port that we just configured on the deployment. Okay, go ahead and hit save, and that should be it. So if we go over to our admin perspective, go into Cryostat, let's see our topology for our classic Cryostat sample instance. We do see we have a application here. It's in the apps1 namespace. It's named Quarkus, so it's the same pod. We can tell this is the same application that I was just playing around with over in the other perspective in the other namespace. And we can see here that it is using JMX, and we have the JVM ID we expect. We have some information about what this application is, just as usual. We do have some things are missing. These are things that are not supported with the native image. So we don't have the library paths, the class paths. Those things are just not supported, but we have a lot of other information here about what this application is. And we can do everything else we would expect. So we can have that target. We can list which kinds of event templates come with it. So that would be our our target things here, the profiling and continuous event templates. We can query the event types. This is taking a second. There we go. We have two here that we don't normally see with JVM mode applications. These two end chunk and every chunk period events. These are specific to GraalVM. And so that's the runtime and compiler that produces the native image. So in OpenJDK hotspot, we don't get those. In GraalVM, we do. The rest of these are pretty much the same as what you would get in OpenJDK. Some minor differences here and there, but they're here. And if you remember, I added a recording as a startup flag for our application, and we can see that Cryostat can see it. We can also, of course, go ahead and create our own applications just however we'd like, as usual. So we can do that. And we can do everything else you would expect. So we can do automated analysis of this recording data. We can view this in Grafana. And so, like I was saying, you might want to do this kind of test to basically test head-to-head your native image applications versus your JVM mode applications, so you can benchmark them and see. Maybe you're considering deploying your services as native images rather than as JVM mode. And so This way you can get real data. You can really compare them against each other and tell, is this going to actually net you the benefit that you think it will? Okay, anyway, that went on longer than I thought it would. Thanks for watching. Have fun.